For today's quiz, we're going to talk about things that bounce and things that don't bounce. If we had a ball and it were smack into the table, it's going to impart a certain amount of impulse to the table. The question for today is, if a ball bounces, does it impart more or less impulse versus if the ball doesn't bounce? We're going to show you the demonstration first and then let you think about it. So here I have an elastic ball, and what I could do is let that one bounce. And as that ball bounces, it imparts a certain amount of impulse into the table. However, if I take the ball, same mass, and I don't allow it to bounce, it's going to impart a certain amount of impulse into the table. The question is, which one imparts more impulse? Write your answer down, and then also mark how confident you are about your answer. All right, for the explanation for this particular problem, let's take the case where we have the ball splatting into the table and not bouncing. We can say that it has a certain amount of mass, and when the mass hits the ground, it's eventually going to stop. Let's say it's going at some velocity initial. Well, I can end up saying that I have a change in velocity that's this big. Let's say it was going 10 and eventually stops, and now that's 0. My delta V would be like 10. The other scenario is going to end up being if I have the ball bouncing, the same mass, and let's say it's still going that 10, and it comes down and eventually is going to temporarily stop as it's getting ready to bounce back. It's going to have the same change in velocity so far that the ball that's splatted, but now it's also going to be bouncing back up. So it went from like 10 to 0 to like, we'll say a negative 10, going the other direction. So that has a much greater change in velocity. And what that has to do with everything is because of this impulse momentum theorem. Let me write that out. And that theorem is going to end up telling us that our impulse and our momentum are going to be together. So I can end up saying J for my impulse is really going to be equal to the change in momentum. And we use P for that. J is for our impulse. If I have the same mass, and I can end up saying where momentum equals our mass and our velocity, another way to write this is I could say this impulse J is equal to the change in, not our mass, because our masses don't change, but I have a change in velocity. Let me make that a better delta. So I've got a change in velocity. Therefore, for a given mass, I can say, as the change in velocity increases, my J increases, which means the ball that bounces is going to have a much greater impulse. It's going to deliver a bigger hit to the table. And so that's your quiz for today. All right, for teachers that are giving a quiz like this, one of the things that you want to consider is students seem to have this vitalism scheme in their head about things that splat or giving it their all versus things that bounce or seem to be more vital, more alive. They have this native or naive physics in their head. So a lot of them think that the bouncing is going to be not affected as much, when in reality we can see that the ball that splats transfers less than the ball that bounces. So just be aware of that.